Hello. Hello, everyone. Hey, yeah. Nice that you're here. Let me check how many people are on the chat. Can you hear me clear? Can you see me clear? Just write in the chat box if everything technical is okay. Hello. Hi, Nahashon. Welcome. Just gonna wait a little bit. Blazo, nice to have you back. I think you were there in the first session as well, and there's Lou as well. Awesome, Lou, that you can make it. Donor 93, so far so good. Hans, hi, welcome back. George, yes, okay, hello, everything good. Kintaras, welcome. I think you were there in the first session as well. All good. Good to see you, everyone. I'm happy that a lot of the guys from the previous session made it as well to this session. Petronella, hi, yes, hello. Nicolas, hi, good to have you here. Arbab, hi, you were there in the previous one as well. Good to have you back. Crystal clear, that's good. That's good to know that the money you invest in some extra equipment actually pays off. Good to hear. Let's see. We got... Yeah, it's not updating yet. Not sure how many people are at the moment here. Otherwise, welcome, Ali. Good evening. All right, so let's slowly begin. Gadgets Pro. Hi, Gadgets. So yeah, for those who were not here last session, so the first session that I did last week, the first session that I did was about cleaning up the blocks of a messy PLC program. So we had a very unorganized PLC application in TIA Portal, and we actually used 1.5 hours to clean it up, clean up the blocks. So we focused on the function blocks, the FBs, the functions, FCs, and the organization blocks. I'm going to give you a very small recap of this last session in a second, so that we're back up to speed. But so that's what we did in the last session. We focused on the blocks, the FBs, the FCs, and the OBs. And in this session right here, we are going to focus on the data of the application. So we're going to focus on the PLC tags, we're going to focus on global data, and we're going to focus on instance data. All right. So yeah, I have a question to start with. I did the same in my last session, but I got a different question this time. Just write this in the chat box. What is your main pain point when you're programming TIA PLC applications? So think more like big picture. So not like I cannot get a run signal to my frequency drive, but more like big picture stuff. What is your number one struggling point? What are you struggling with in TIA Portal, or where could you see yourself getting better? What would be valuable to you for TIA Portal? If you can just write that in the chat box, then I'll read some of the answers. Hi, Thomas. Per Olof, hi. What are your pain points? Just write in the chat box, what are you struggling with in TIA Portal? Is it structure? Maybe you're having a problem structuring. Maybe you're not really into ladder logic, into SCL. You have some problem with the programming itself. Arbab said structure to me is an important point. All right, then you're definitely in the right place, Arbab. Technology objects, says Camille, yeah. That's a different section. You know, I do a lot of motion, so technology objects has motion, it has PID controllers. It's a different section. UDTs, otherwise, then this session is going to be very good for you. Structured program for a huge project, Ali. Saber says, understand all the features and finish the project without any problem. I mean, I would say one of the biggest things there as well is, yeah, understanding the features of TIA Portal, knowing how to learn to work with TIA Portal, but I would say finishing a project without any problem, one of the main steps you'd have to take there is as well structure, organize your application in a proper way. All right, so that's good. I think you all are in the right place. So if you're struggling with creating structure in TIA Portal, or you're just getting started and you just want to get better at organizing your PLC application into a TIA Portal, then this session will definitely bring you lots of value. All right. So one thing I'd like to mention, I told this as well, Jaap says as well, structure is most important. Yeah. One thing I like to make clear is that it doesn't really matter which version of TIA Portal you're using, or it doesn't really matter which language you prefer when programming TIA Portal. So the concepts, the teachings from this session are independent of the TIA Portal version. They're independent of the language that you're using in TIA Portal. I would even say it's independent of TIA Portal. You could use those same principles and you could apply them to Rockwell, to Beckhoff, to BNR. It's all about structuring a PLC application, and that's kind of a global thing. It's not just limited to one specific vendor. All right. At the end of the session, there will be, just as in the last session, there will be a 15-minute Q&A, questions and answers. So if you have any questions, please keep them until the end, because I will be focused here on the software. So I will watch the chat once in a while, but most of the time I will be focused on giving you the presentation, the session, the workshop. So if you have any questions, write them down or remember them and ask them to me at the end of the session. There will be plenty of time. I go a bit over the time. Last time I went a bit over the time. So I'll make time for you to answer your questions. Keep them until the end. All right, so let's start with a quick overview of what we did last session, just a couple minutes to get back on track. So what we did last time, I'll open TIA Portal here for you, is that we started with this piece of software right here, which was a really messy application. You see, we had a huge list of blocks, just, yeah, it's quite a mess. I mean, for me, it's a mess. Maybe if you're used to working with this looks like normal, but for me, this is like an unorganized, just a bunch of function blocks just thrown all underneath the program blocks. There were a couple of folders here, which made no sense. Module and other, naming was all over the place. And what we did with this application is we turned it into this application. So what you can see right here is that we created program groups. We made a group called organization blocks where we put all the organization blocks underneath. We made a separation between general modules like an air supply, an alarm, a conveyor, line control, everything that has to do with the application, the machine, the process as a whole, so not specific processes. Next to that, we created a process group for each of the specific processes of this application. And in this case, we were working with a molding line, which is a line that pours a liquid product into a mold. It cools it down, and then it removes that product from the mold, from which it goes further to a buffer, a packaging line. So the different modules that we defined for this molding line was an upstream module. That's everything that happens before the molding line, like buffer tanks, maybe the preparation of the liquid. Then you would have the conditioning module, is where the molds would be conditioned. They would be maybe cleaned, or they would be heated up to have the right temperature before pouring liquid into them. The next module would be the depositing module. This is where you actually pour the liquid. Can be anything from candles to soap, to chocolate, to epoxy. Any type of product that you can make on a molding line. So you would pour that in the depositing module. The next module is settling, where you should, basically the aim is to get the product to be in all the corners of the cavities of your mold, to make sure that it fills the whole mold, so you don't get any empty spaces. module number 5, or the next module would be the cooling module, where the product is being solidified, so from a liquid state to a solid state. Afterwards, you could typically have like an inspection, like a vision system, a weighing system. So a vision system maybe to detect bubbles in your product, a weighing system to check if the weight of your product fits with the specs. And then afterwards, the final step on the molding line itself would be the demolding process. And this is where you get the solid product out of your mold. It can be through a hammer, can be through vibrations, blowing with air nozzles. There's different type of equipment to get your product out of the mold, depending on which industry you're in. And then the final the final process module that we defined was a downstream module. That's everything happening after the molding line. So that could be, for example, a buffer to store products, or afterwards then a primary packaging, a secondary packaging. So those were the process modules that we defined in the previous session. Then we made a group for motion, where we where everything that has to do with motion will be added. We made a group for safety. And finally, we made a group for data with all the data blocks. And as well, we defined a library group. And this is where all the reusable functions, FCs, and function blocks were stored. And again, we made a group structure depending if those reusable blocks were part of general modules, process modules, motion modules, safety modules, or vendor modules. That's like third party, like for example, weighing system by Mettler Toledo. Or this is a company that makes blocks for, or that makes connections for an SQL database from a Siemens PLC, a TIA PLC. So these blocks had to do with that. So we put them right here under the vendors. And then we had finally a group with some help functions. That's some things you might use in more than one blocks. For example, converting a real format to a time, a filter, a PID control. You can use a PID control for more than one thing. You can maybe use it in a heater block and a cooler block, a shaker block. So these are like help functions that would be within functions. All right, so I mean, that's basically a small overview of what we did in session 1. Now, session 2, as I told you, the goal is to reorganize the data. Let me just close this. So we're going to do that in 3 steps. First, all right, I'll close all of this here. First, we're going to have a look at the PLC tags right here. Then we're going to have a look at the data, which in the previous session we stored right here. So all these DBs we are going to reorganize. And it's going to be very interesting because I'm going to show you how you can make really nice structures within those DBs. And then finally, I'm going to have a look at instance DBs, and especially we're going to have a look at single instance DBs versus multi-instance DBs. And I'll tell you a little bit about when to use which type of DB, when it makes sense to use a multi-instance, when it makes sense to make a single instance. All right. So I hope you like the program for today. So let's get started. So number 1, PLC tags. That's where we're going to start. And right here we have the PLC tags. And as you can see, we have just one huge table, which is called default tag table. So that's where I would say that's the first mistake. I mean, if you make a new tag table in TIA portal, for example, right here, it's called tag table _1. I mean, please start by renaming this tag table into something useful. You can just click on it and press module inspection, for example. I mean, do not leave your tag tables with the default name, because it's just going to be a guesswork of what's inside that tag table. So that's the first tip I would like to give you. Now, when we open this tag table, you can see we have here everything from markers. These are system memory bits, clock memory bits, Then we have a bunch of inputs. We have outputs here. I mean, it's just a mix of everything. We have digital inputs, digital outputs, analog inputs, heating fans, cooling fans. It's all just thrown into one big tag table. I mean, that can definitely be cleaned up much better. We can make that much nicer. I think there's some markers here in the end as well, right? You have just some general markers here. Let's start, maybe let me have a look here. Let's start by creating first some groups here for the PLC tag. So we are going to, same as we did with the program blocks, we are going to segment these different inputs and outputs depending on the function. So we're going to make a group for general PLC tags. We're going to make a group for process PLC tags, a group for motion, and a group for safety. So let's start with that. So I'm just taking over the same numbering as we did here with the program blocks. So 110 general, 130 process, 150 motion, and 170 safety. All right. And what I'm going to do next is I'm going to split up the inputs from the outputs. I mean, it depends a little bit. If you have a smaller application, you don't need to do that maybe. But if you plan to work on making more complex and bigger applications down the line in the future, I would suggest you would make a clean cut between inputs and outputs. It will make it easier afterwards to find your data, to find out where your inputs are, where your outputs are. So here for general, I'm going to create both a new tag table called general inputs and one that's called general outputs right there. And I'm going to use this same type of structure with inputs and outputs for process, motion, and safety. I'm just going to start by copying them, and then I will rename them. That's the easiest. Just by the way, copying is just simply Control-C, Control-V in TIA Portal. So, I mean, try to use the keyboard shortcuts. They're very handy. Control-C, Control-V, that works perfect for these kind of things. Process, motion inputs, motion outputs, and then finally here, safety inputs and safety outputs. All right, yeah, like that. And the next thing I'm going to do now is I'm going to move the IOs here from my default tag table here, from this huge table. I'm going to move them into these different tag tables. So I'll first start by kind of reorganizing them, inputs first, then outputs, and then the marker bits. The marker memory. So customer spare inputs, I will put that under general inputs. I mean, I don't know yet if they are going to be used for process that they are spares. I'll just put them under general. Heating fan, cooling fan, shaker, those are all process inputs. So they go right here. Main cabinet power supply, servo, power supply, those are general inputs. I mean, they apply to the application as a whole. They're not like process specific. Cooling fan, heater, vision status, shakers, vision push button, that's all process. Push buttons for the line, you know, to start the line, stop the line, to reset faults on your line, on your machine. reset the safety. Those are general inputs, so we put them right there. Then we got some safety inputs, so those go under safety. Depositor, that's again process inputs, that's the depositor module process inputs, there we go. Other push buttons inputs, safety, which by the way are easily recognizable by the yellow outline right here, so that's an easy way to spot the safety IOs, inputs, weighing push button, so the weighing, that's part of the inspection module, so a process module. Again, some safety inputs, e-stops and guards, mold clean, that is part of the process module, the preparation of the mold, conditioning, so process. These are some homing sensors for motion, for an axis, for a servo axis. So these go under motion inputs. There we go. Then we have some more guards, e-stops, safety inputs, vision, again process, that's inspection, reset faults, push buttons, general inputs. I hope you're starting to see how this works. So you just define in which module or in which tag table it belongs, and you just move it. Heater, that is process inputs, and we are almost through with the inputs. I think the outputs are coming. It's a bit less, so that should go a bit faster. Safety inputs, air supply, that's a general module, air supply. Cooling and weighing, again, those are process inputs. And finally, again, these are torques, ProfiSafe, receive and send commands to access. I mean, the ProfiSafe, that can be discussed if it goes under safety. Right now, I'll put them all under motion. There. And then now we have the outputs, depositor output, that's a process output, depositor module. These spare ones, the customer spare ones, I'll put them general. Safety outputs, STO, save torque off for frequency drives, and for servo modules, they go under safety outputs. Available analog outputs, general outputs, cooling and heating fans, vision commands, shaker, mold clean, that's all process. Another safety output. Vision, hammers, mold clean, that's all process, that belongs to specific process outputs. Push buttons, lamp push, so the lamp, the actual indication in the push button that you pressed it or that it's turned on, those are general outputs because they're for the start and the stop of the line. All right, almost there. Heater and cooler, process outputs. Air valves, that's safety outputs. Light beacon, that's the indication you can have on a line with different lights and a buzzer to show if a line is running, is faulted, is ready, maybe needs some product. That's the beacon, that's a general output. Mold clean, process, and weighing is process as well. And finally, the motion sent telegrams for the ProfiSafe, I'll put that under motion outputs. And that's it for the inputs and the outputs. You can see they all have some content in them, 31 here, 41. So yeah, we can close that now, makes it look a little bit more neat. I mean, you might think like, okay, do we really need these folders? I mean, I would say one thing you could do is just throw them all out here. If you think that's one click less to go to open this folder and then go to general process. So, I mean, sometimes I would just put them like this as well. But But if you get, again, bigger structures, bigger applications, I would probably still prefer to have the group structure, and then underneath the group structure, you would have the tag tables. That makes everything just a little bit more neat, I would say. So what we have left now is some marker memory. We have some marker memory. I'm just checking here. Yeah, there's something I missed here, but I'm going to show you that in a sec. Let's clean up the marker memory first. So what we have here at the top, this is the system memory bits and clock memory bits right here. Marker 10, 0 until 10.7, and then marker 9. That system and clock memory, which, I mean, you can actually see if you would go in the device. I'll quickly show you where you configure this. So in the device here, in the PLC device, if you would go here to system and clock memory under general, then you can see that there was defined a system memory byte and byte 9 and a clock memory byte and byte 10. So that's actually the ones that have been automatically generated here. What I typically do is I'll make a separate tag table for that just to make it clear. So I'll call that system flags. There we go. And I'll throw these ones in here. I mean, and what I have left right now are some system memory markers, some marker bits and marker bits, bytes, double words. And what I would recommend you is to get rid of these. I mean, in Semantic Manager, you know, the classic step 7, this was still appreciated and it was still used by many PLC programmers, but I mean, TIA portal is a different beast altogether. It's actually from Siemens. It's actually not. I mean, Siemens tells you it's not a good idea to keep marker memory in your PLC application. The main reasons being that they are hardware dependent, so not every PLC has the same range of marker memory. They are as well slower, so the performance marker memory is accessed, so the read and the write is accessed at a slower rate than global data, for example. Sorry. And the third one, and that's actually the one that I think is the most important, is that you cannot structure marker memory. I mean, you can only use single data types, so you can use bools, int, reals. You cannot use a UDT in here. So for me, that's the biggest downside to marker memory. So what we're going to do, except for this commissioning bit here, we're just going to delete all of these. And I'm going to show you afterwards what we're going to do instead. So, but for now, I'll delete these. And of course, if this would be an actual application I would work on, I would not just delete them without taking notes. I would write down or make a screenshot, put it in my log file, and I would write down, I deleted these, and remember to make structures out of these or to add these to global data, which is going to be the next point. So the one thing we have left now is the commissioning bit. And I'm going to do the same as with the system flags. I'm just going to add a new tag table called commissioning. Again, that makes it very clear if you're doing a commissioning and you made some bits. Again, I would not recommend making a marker bit. I would probably make a DB called DB commissioning and then put some bits in that DB. But if you plan to use a marker bit, just put it in its own tag table like this. And then it's very clear when you're in the software, okay, commissioning, and then you can look at the commissioning bit, you can do a cross-reference, see where it's used. All right. Let's have a look where we are. So that's the system memory. I'm just quickly gonna go back to the inputs and the outputs. what I would like to show you before we're going to go to the global data is I would like to show you how some inputs or outputs that belong together, how you can make a structure from that. So how you can actually make it more organized. And let's see which example I took here. Yeah, I mean, if we take the shaker, for example, let's just remove this one, the input words we're not going to need here. So let's just say a shaker, you see the communication is input word 960 and 962, the status words SW, and the process value, so the speed process value of the VFD, the status word of the VFD. These are right here defined as two separate input words. But what you can actually do in TIA Portal, and I'm going to show you that right now, is that you can create a UDT for this. So you can put both of these in one structure. So to do that, we first go to the PLC data type section right here. Okay, let me just check here first. Yeah. And we already seem to be having a frequency converter command and status. So the first word, input word here, which is probably the status word. Yeah, this is the status word. So these are all the status bits in the status word. This would be this input word right here, the first one. And what I'm going to do is I will rename this to UDT VFD status. And I'm not only going to put the status word in here, so not only this one, but I'm going to put as well the process value in here, so that I have a structure with both of these input words in it. So the easiest way to do it, I can just insert a row here and put status word data type struct, so it's defined as a structure. And then I'll move all of these flags, these bits right here. So that's the status word. And then after that, I put, let's see, what was it called? Process value, exactly. So that's the VF, that's the actual speed. It's going to be a word, actual speed, word. There you go. And that would be the structure for the complete input area for one VFD communication. And what we do here then is, instead of having these two, I'm just going to replace this by one structure. So I could take this one, for example, UDT VFD status. It's not an input word, it needs to be defined. It turned into a pointer, but you can just open this and then accept it. See, now it accepts, and you can see, okay, we still need to rename it. So let's just say VFD status. That under this we have the status word at 960 and the actual speed at 962. That means this 962 we don't need anymore, because actually everything, the whole input communication, so everything that comes from the VFD now just comes directly into the status word. So that's another way to clean up inputs. We can do exactly the same for the output here. This would be the output word, the control word, which we find right here. Process output, control word, and the set point, or the set point speed. So if we take the same one, 960 and 962. So we're just going to put those as well into one structure. Where were we here? Yeah. So UDT VFD command, not status, command. And what we're going to do here is we're going to create a control word like this, which is a structure as well. And we are going to add all these flags underneath. So that's the first part of the communication, of the command communication. And then we'll add the set point speed, which is a word. And that will be our command communication to the VFD. So if we now go back to our process outputs, to our tag table right here, it means that we can replace this word by the VFD command, UDT, the structure, the user-defined data type. We need to change this one to the pointer. So if we open this one now, you can see I have the control word at 960 and the set point speed at 962. That means here 962, this one can be removed. And I can easily do it with this as well. So shaker 1, UDT VFD command. There we go. Then we've done it for both shakers, right? Like this. And we remove the set point here again. And on top of that, let's just call them command. So I hope you can see how this makes things more structured in your input and your output area. So instead of, I mean, this is like a small example with a shaker where you just have two words, where you had two words after each other. But imagine you have a communication to I mean, there's VFDs or VFD communications that have more words, that have maybe 4 words. There's, I think we have an example with here with a weighing cell. You see we have a communication with 3 different tags. So all of this, these 3 weighing tags, outputs, these outputs, you could as well just pour into an output structure, and then you can just replace these 3 lines with just one single line. And what's as well the good thing about this is that there's less chances of errors. If you have more VFDs, you just copy paste one and you give the start address, you point to the start address, and you don't have the same risk for making errors. You don't have to type in 3 different addresses. You just have to type in one address. So that makes it less prone to faulty programming. So you'll make less faults like that. All right, let's close this one. Oh no, I think we keep it open because there's one last thing I'd like to point out. I'm just going to do the same here for the shaker 1, because I'm going to use that a bit later for examples. So shaker 1 is UDT VFD status as well. And right here, we're going to point as well. So there you go. Okay. Oh, what's the time? Okay, 40 minutes. One last thing I'm going to touch on right here before we go on to the data itself, the global data, is renaming this. I mean, at the moment, everything is just written in capitals, which is not something I normally do. I mean, it depends a little bit of the client or the company you're working with. Maybe the software department you're working with, they like to use that. Personally, I try to avoid using all capitals in my naming conventions. I can just give you an example of what I would do to make this more clear when it comes to naming the inputs and the outputs. I'm just gonna have a look here. Yeah, I mean, what I normally do is I always start the name with the type of input. So for a digital input, I would write DI underscore. Then I would write the unit or the module. So to which unit or module does it belong? So in this case, a heating fan would be the heater module. Then the device, which would be the fan, and then the kind of equipment or the kind of, in this case, a local isolator, which type of switch. So then local isolator finally followed by the device tag. So the Q2, that would be a reference to the hardware drawings. You probably have a set of hardware drawings for your machine, and their Q2 would reference to the local isolator, the designation, the device tag in the hardware drawings. So yeah, the same here for the motor circuit breaker would be a heater fan, motor circuit breaker. Sometimes I would as well use an abbreviation like MCB. It depends a bit on the company you work for. Motor circuit breaker Q1. So that's for digital inputs. For analog inputs, I would just use, I mean, this may be a bad example because these are the VFDs, which we just converted here with a structure. But if we take, I think there's some temperatures as well somewhere. Let me have a look here. A heater temperature. So I would take an analog input to start with AI. Again, small heater, air, and then, for example, temperature inlet, B2, temperature outlet, B1. So you see, this kind of makes it easy. If you have to add these inputs or outputs to your program afterwards, you just start typing AI or DI, followed by the module, and TIA portal it autofills. Normally that's standard enabled that you auto fill your entry. So if you start typing AI, it will give you the possibilities, a list with possibilities of tags to choose from. So if you keep that kind of structure, then it will be easier to assign inputs and outputs to your application. Maybe I'll give you some example here. For example, for communication, I would typically use API, which stands for Application Programming Interface. So I would use an API for a communication to a third-party equipment. For a VFD, you could start by putting VFD in front, VFD shaker, because it's a structure, it's not a DI or AI, it's a structure. So VFD shaker 2 status, VFD shaker 1 status. And outputs, it would be the same. It would be for digital, I would use DO, hammer 1, for example, on, followed by the device tag. Or what else we have here? Yeah, an analog output would be AO, heater. Again, first the module name, then the unit on the module, which would be heat. You could have a fan as well. If you had a fan, it would be fan, but this is the heating part of the heater. So heat on, for example, Q5, heat on, Q3. All right. So that's it for the inputs and the outputs. Yeah. I think we are done with this part. Let me just have a quick look here that I make sure that I told you everything that's important. Chris, keep your questions. I mean, I will answer all of your questions, but keep them until the end, because I will answer your questions during the 15-minute Q&A at the end. All right. That's it for the inputs and the outputs. So this was the first step, the cleaning up of the tag table right here, the PLC tags. So you see we have a nice structure now, general process, motion safety, with 2 tag tables for each, one for input, one for outputs. And we reorganized a little bit our system flags as well. They are in a separate system flag tag table, and a bit for commissioning right here. I mean, I would typically write like AAA to start, and then I would write something like to do, because then, yeah, it's easy to find back. I would as well, for commissioning, write which specific thing I would be commissioning, motion or torque. I would make a different flag, a different bool, a different bit for each section of the commissioning. So you don't just have one bit to do everything. That makes it a little bit more, makes your commissioning a little bit more organized. Okay, so part 2 will be the global data, and that will be very exciting, because there's a lot of things, we're gonna go through. I'm gonna talk about, keeping an eye on the time as well, because last time I got a little bit over the schedule, but I'll try and keep it within the 1.5 hour limit that I set out. So global data. So right here, this is from session 1, everything, all the DBs that we put under the data folder, the data group. So you can see there's an air supply DB, which is an instance database data block, and you can easily, I can show you how you can see that. You go to properties, and right here, you can see under type that it says instance DB. It belongs to the function block FB general air supply. So I can see it as well, that it's because it has the underscore DB at the end. That's kind of the standard TIA portal, the standard thing that TIA portal would probably give you as a default when you create an instance DB. Then you have some servo DBs. You've got depositor control, depositor servo, some HMI alarm commands. I mean, it's a lot of different blocks. Again, it's a little bit of a mess. There are 3 recipe DBs, some safety instance DBs, SQL, and finally there are a couple of safety blocks right here. I mean, what I'm going to start with is I'm going to delete all the instance DBs, just so we don't have such a large list of blocks. And the thing is that they are always going to be, I mean, when we later going to call the blocks in the actual, in the software, when you call the FBs, then these instance blocks will be generated again, and I'm gonna show you how to do that then. But for now we don't need them. So I'm just gonna start by deleting everything that has an underscore DB in the end. Which is many blocks, as you can see. So we're gonna end up with a nice little short list of blocks. So everything with underscore DB, let me just check that I didn't forget anything or took one too many. DB, that looks good. Yeah, so those ones are gone. So you see our list is way smaller now. Yeah, and now, I mean, we have these 5 HMI blocks here, and you know, for me it seems they are going to be the blocks that communicate with the function blocks of this software, because you have a setup. We can just go through them. A setup block, and here you can see there are some setup parameters for example, conveyor maximum speed, acceleration, deceleration, jerk, depositor max speed. There are some shaker minimum and maximum hertz, so minimum allowed hertz, maximum allowed hertz, cooling temperature, some scaling configuration. So basically this HMI setup block is a configuration block. Yeah, and that's going to be important for later. I'll show you how we're going to use that data. We have a status block, so that's probably gonna, yeah, that has the status of some units, shaker status, running at speed, faulted, cooling, running, faulted. So these are status I can see for both process modules like shakers and cooling, but as well there is some status bits from general modules like alarm, active, reset horn, air pressure. That's actually part of the air supply module. some recipe status, an actual recipe number, name, etc. So those are status bits for the application. Setup, we went. Command, they're commands. Start the line, stop the line, the line speed, move forward, main conveyor forward. Buttons are in here. A command for air supply. So again, it's a mixed bag of commands that are being used for process-specific modules and for general modules. So basically, I hope you start seeing everything is all over the place here. So we have both process modules, general modules, all spread out over these 5 dBs. And I mean, maybe you're thinking, hey, at least here there's a separation between commands and status and setup. But I mean, I'm here to tell you that, and I'm going to show you that there's a much better way of doing this. But let's first check these last 2 HMI blocks here. So we have parameters. That's probably going to be input fields on the HMI, entry fields for example, a shaker speed and after runtime, a conveyor speed, cooling set point, some hammer times, probably to do with how it should hammer on the mold, a minimum air pressure, a vision recipe number. So these are parameters. And finally, there's an alarm HMI, which has, it has alarm triggers. You can see that by the fact that they're words. So because the HMI uses a word data type for triggering each bit in the word, or using each bit in the word for triggering a specific alarm on the HMI. So in this application, they have made a word trigger word for each equipment on the line, for shaker, cooler, as well for air supply network. Okay, so I opened these quickly just to show you that all our modules are divided over these 5 HMI blocks. And what I'm going to do is I'm going to show you a better way to organize this. So what we're going to start with, same as we just done with the library, same as we've done with the program blocks, is I'm going to start by making groups here again to create some kind of segmentation in the data. So I'll create the same groups as before, and I'm using 210 now to keep the same kind of numbering. You see for library we did 3, 10 for general, 10 general, process is 30, motion 50, safety is 70. So we're in the 200 range now. I'm doing 210 for general modules, 230 for process modules, 250 for motion related data, and finally 270 for safety. There we go. By the way, I mean, I haven't been looking at the stream itself. If the stream or the sound at any point starts to get worse, then just write me on the chat box. I should normally keep an eye on that. My internet connection is okay, but you never know what happens. So if the quality of the stream is bad or getting worse, please let me know. All right. So we created these groups right here, and now we're going to move the blocks to the correct groups. These HMI blocks, I'm just going to leave them here for now because we're gonna reorganize that. The servo, that is motion, so we'll move that to the motion area. Again, these blocks, they have a yellow outline, which means they're safety, so I'm moving them to the safety group. The recipe, that is that's part of the general module, and I mean, you can see it right here just to show you. We had a recipe handling right here from the previous session, so that's as well a general data. And SQL for Siemens, that is actually still an underscore DB. So that was one instance DB that got lost in the deleting process. So I'm going to delete this right now just to show you right here, instance DB. So I mean, when I get software like this, I don't feel bad about deleting the instance DBs because they can be regenerated, and they don't hold, normally shouldn't hold important data. Global data, of course, you should not delete straight away. You should first have a plan on how to restructure it. So that's everything we had here organized under here. There's still, yeah, you can see there's still an empty process one here. We have nothing. And what I'm going to show you right now, let me check. Yeah, what we're going to do right now is we are going to make a specific DB for all the general modules, just one DB. And afterwards, we're going to do the same for the process. So let's start with that. And then afterwards, we're going to make the structures, and it will all get more clear then. So I'll start here by adding a new block under general, a data block called DB general, like that. And I'm going to do the same right here under process. I'll just copy paste it. That goes easier. DB process. So those are going to be the global data that contains the data for, on one side, the general modules, and on the other side, the process modules. I mean, at the moment, they're of course still empty. There's nothing in there. But we're going to change that right now. These blocks, these blocks, I know if I'm not really sure yet what I'm going to do with them, then I'll put them under a to-do folder, so I know that I still will have to have a look at them later. Makes it just a little bit more organized when you're working with an application that you don't have too many blocks just lying around. What we're going to do now is we're going to make a structure for, I'm going to show you how to make a template structure, a basic structure for a module, and then we're going to add those structures to the general DB and to the process DB. So to do that, we go to the PLC data type section right here. Yeah, and you see it's a little bit messy here as well. There's a lot of different data types. Just put as, just a list of data types without any real structure. So what I'm first going to do here is I'm going to create, once again, the same group structure as we've done multiple times before. 110 general, 130 process, 150 motion, and 170 safety. And I'll put one last one, which is called vendor, because I see there are some data types there which are not by the programmer, but are by a vendor specific. So the vendor specific data types would be this SQL for Siemens interface. So I'll make a group here called SQL for Siemens. So this UDT goes here. So that's a UDT that was not created by the TIA programmer. That's a UDT that's been created by this company, SQL for Siemens. There is as well this SAI, which I know from working with this type of UDTs. This is from Mettler Toledo. So this is a weighing cell, a UDT for a weighing cell, or part of a control of a weighing cell. So we move that under here. So these UDTs are already in place. Now we're going to move the existing UDTs to the correct group. So upstream vision weighing unit, that's all process. Yeah. Safety, we can move that to the safety group right there. Downstream, that is as well process. OPC communication, that is general. There's one called unit here as well. I think it's process, I'm not sure. You would have to go inside and look. And finally, let me share. Okay, we have a couple of folders right here as well. Motion, all right. So there was a folder for motion. I'll just move these over here under motion. We delete this one. And we have some UDTs for a SQL database communications. So that would be, yeah, that would be under general. That's a general thing. And then we have UDT, VFD command, VFD status. Yeah, those are more like help functions. So I'll make a new group here called help. Help UDTs, for example. And we put them right here together with the system flags. Okay, so now all our UDTs are PLC data types, as they're called here. They are grouped together. They're segmented. And what I'm going to do now, what I was mentioning before, is I'm going to make a template structure, one structure that we can use as a template for each module. All right, so for example, if we start here, if we have a look at our general modules, you can see we have air supply, alarm, conveyor. So I'm going to create a separate UDT for each of these general modules, and then I'm going to add them to the DB general right here. Afterwards, we're going to do the same for process. So if we take air supply as an example, it's called FB General Air Supply. So I will use the same naming. So under General, I'll first put all of these under To Do. So we again clean up a little bit here. So General, add new data type. I always start with UDT because that's, again, user-defined data type. That's easy. Afterwards, if you want to add them as a data type, you just start typing UDT, and then you get everything related to user-defined data types. And this one we're going to call General Air Supply. Yeah, just like that. And it automatically opens. And I mean, what I typically do, and this is, you can see this is well related to this. I will have a, for each module, I will have a config area as a struct. So this will be for configuration, for any configuration. Let's try write that one correctly there. Configuration of the air supply module. And that would be, yeah, that would be the same as the HMI setup. So you see right here in HMI setup, we have these three parameters here: air supply, scale, minimum, maximum, minimum, and time delay. So that would be probably what I would put here in the configuration. So now I just copied them to show you. So this would be an air supply. I'm just going to write it: air pressure scale. Okay, that was the max. A real, the min. I normally put the minimum first. That looks a little bit nicer. Minimum, maximum, and then air supply timeout delay. air pressure timeout delay. Or maybe it's better if I start like this. It's a time, so I'll put a small t in front here. Time, air pressure, timeout delay. So that would be the configuration area. Then I would have a button area. I mean, it depends a little bit. Sometimes I put the buttons under the command. Sometimes I make a separate structure for this. For now, I will show you how to have a dedicated button area. This would be all the buttons on the HMI related to the air supply. And if we look here at HMI command, you can see we had one button here for air supply. So we're going to put that here in our structure button. Let's call this air supply on, for example. Yeah. So that would be the button on the HMI to turn on your air supply. The next part of the structure would be parameters, and you can probably see where I'm going with this. Parameters. HMI parameters. So here we had a minimum air pressure, which would be a parameter from the screen, a real minimum air pressure. Minimum air pressure. Then I would have a command area, command structure. And I mean, for those of you who've already taken my courses, you probably recognize this from some of my material. So HMI command, the button we already used for the air supply. You see we had a command here for air supply on. So that would probably be a specific command, not used in the HMI, but like an internal command. Air supply on. A status area. Status. Let's look if there's anything in the HMI status block for the air supply. Air pressure, okay. So the status from the air supply module that the air pressure is fine, that you can start your line, and that's a Boolean. And finally, a fault structure. By the way, you can see I like these small abbreviations. I mean, you can write them out, but I'm used to, I think these are generally accepted in the industry: command, status, fault, parameter, button, config. At least in the type of industries that I work in, these are generally accepted abbreviations. But I understand as well if people would like to write them out to make it more clear. I would always try to keep the complete tag name to make it not too long. You know, that your logic is not just filled with super long names, because that kind of makes it more tricky as well to read the logic. So try and keep it clear. You know, use some abbreviations that are accepted in your field of work. But yeah, don't make them too long as well. I know TIA Portal allows you to write, I don't know how many signs for a name, but it's a lot. But I would not suggest to use that complete number of characters. So finally, for the fault, we have the triggers. So for example, for the air supply, there's a word trigger here. I mean, we're just going to use that here, a word W trigger. So that would be the fault structure of our module structure. All right. So what I've done now is all the air supply data, all the tags, the variables that were spread over these 5 different DBs, I've basically put them all together into one structure. And this structure I will put now into the general, the DB general. I'll go the official way because I think that's a bit easier to follow. Data general, so right here I would then put air supply, and the data type would be UDT general air supply. So you see, this is global data, so this means this is what we will use as communication between the different blocks in our application. And everything that has to do with air supply is now all modular. It's all containerized. It's all together in this block. So the configuration, the air pressure, the scaling of the air pressure sensor, the button from the HMI, the parameters from the HMI, the command, which is maybe used internally in the logic somewhere, and the status, the fault. It's all here in this block, and that just means it's much easier to troubleshoot. If you now need to troubleshoot the air supply system, you don't need to go and open 5 different blocks and look at things, look at data. You just need to open this one DB general, and you can look inside the structure. It's the same when you trace data, when you're going to record your data over time using a trace. It's much easier to add the different signals of the air supply if they're all within the same DB. You just have to start typing air supply dot and then config dot and then the parameter TIA portal autofills. So it's very easy just to add these things quickly to a trace and to troubleshoot, to debug any faults that you might have in the air supply system. Let's just do a couple more examples here with some of the other modules. So this is a template. So I mean, I just added the specific tags for an air supply module. Of course, we would have to do that for each new module that we're creating. So I'm just creating 5 here, quickly copy paste. Air supply, let's see which other ones we have. I'm just going to take a couple here from the general. Alarm, conveyor, and line control. So alarm, conveyor, line control, and yeah, let's add a state handler as well. We had that as well in there. I'm not going to make all of them because then we're never going to fit everything into 1.5 hours. But okay, so I'll just take these 5 ones as an example, and I just add them here then. Alarm, conveyor, yeah, that was almost correct. UDT general conveyor, line control. I'll just type it like this. State handler. So you just fill this up with all the modules that you have. I mean, I just took these 5 as an example. Let me have a look at my notes. Okay, so I mean, now that we have made this DB general, I'll quickly give you an example of how you actually use it into your logic. So this is a general module. So air supply, for example, let's take that one as an example. So under FC general modules, you would call the air supply module. So I just pull it over here. I'm not going to do the instances yet. That's going to come later. So this would be my air supply, my function block. And then I would simply add this structure that we just created I would just add that to the in-out air supply, and I would use the same UDT that I just created, UDT general air supply. And then you can see you have your whole structure right here available. I mean, the advantages of using the in-out is that you are calling it by reference, not by value, which means it saves on system resources, basically. One thing lately that lately that I'm thinking more about this, but I mean, an in-out is smart and saves resources, but the big disadvantage of using an in-out is that it's difficult to troubleshoot, because you cannot, if you use one of these tags right here in the logic and it's used somewhere else in your logic, it cannot cross-reference through the in-out in TIA portal anyway. That's a disadvantage. So another way of doing it is putting all the necessary signals as inputs and outputs. You would use more system resources, but you will it will help you with troubleshooting, but actually finding your data when you do a cross-reference. So we've added to the in-out, so we need to update our block call, and then right here you see that's the new structure that I've added, and right here I would just then add the DB general air supply structure, just like that. And right now you can have logic in this air supply that uses the configuration that writes to the status in your module structure. It reads the parameters from your structure. You know, this structure would also be tagged up in your HMI. By the way, you can do that as one full structure, so just one tag that you need to add to the complete structure. That's another advantage. So you don't need to, in your HMI, you don't need to put a separate tag for each of these individual tags. You just add the complete structure as one thing in the HMI. So parameters, buttons from the HMI, that comes straight into the block. It's like a gateway, so the block read and writes to the structure. And if you need to use this air supply somewhere else, for example, the air pressure OK signal, right here you have, we defined a status bit right here for air pressure OK. Then you can just add that somewhere else. For example, I'm just going to give a quick example here. If you would have a conveyor and you would need an air pressure OK signal here, then you can just add an input right here. Or air supply, okay, I can't remember which one it was. But let's say you need to use that right here. Air pressure, okay. DB gen, then you add the specific status, air pressure, okay, from this module, from the modular structure. So that's how you communicate data between the blocks using these modules. I'm just keeping an eye out on the time. Yeah, so we've done this now for the general modules. Yeah, maybe. Yeah, what I can still show you is how to use the configuration. So it has a configuration area, this module. So what I typically do is I'll have a configuration block, which I call in a first scan cycle, for example, which is part of the general modules. And then you can do, for example, you can type configuration air supply. And then we just use the configuration structure from the air supply, the minimum scale from the air pressure, for example, 0 bar. And you can see I like to use SCL or like a written text for this, because assigning parameters is easier like this. You just make a list of parameters like that. It's easier than, for example, ladder logic or function block. So just for a list of assigning values to parameters, I would suggest using SEL because it's easy to read. Maximum pressure scaling, 6 bar. So this is, for example, how you can use a configuration function like this to configure configure each module. Okay, that was that. Add module structures to DB process. Yeah, yeah. So now I've made the modules for general. Now we're going to do the same for the process modules. And what I'm going to do here is I'm not going to define, here I defined a UDT for each module. Here I'm going to do it a little bit different. I'm going to define a UDT for each unit, kind of. Because the reason I'm going to do that, not per module, is because a process module is a little bit bigger. It has a little bit more blocks than a general module. Just an air supply module just has the air supply. But for example, the settling, that's the settling module, that's to get the product to the corners of the cavities. By using a shaker, for example, you might have more than one shaker in this. You might have 3, 4, 5 shakers. So what I like to do here is to actually make a UDT for the unit, for the shaker, and then call this shaker 5 times in the module. I mean, it will get it will get more clear in a second. So I can show you right here. Let's start by that. Here as well, these ones I'm going to put in a to-do group so they don't fill the screen. They don't, yeah, so it's easier to see. So I'll copy the air supply. I'll call this one process shaker, for example. Yeah. And then I'm not gonna, it will always have the same structure. I would need to have a look in these DBs again, right here, in these HMI DBs to see which specific things are shaker related. But so I would make a process for a shaker, a depositor, what else? A heating fan, a cooling fan, for example. Heating fan, cooling fan. You might have, for example, a water system for a depositor system to make sure the water system gets to a certain temperature. Those are just units, some process units. And so I have not created a UDT for the module itself, but what I'm going to do now is in the data block of process, I'm going to create a structure for all of these process modules. So upstream, I will have a structure. I'll just put spare for now. Like this. I'll just quickly put them up here. Conditioning, depositing, settling, cooling, inspection, demolding, and downstream. And then underneath here, I would put these data structure which I just generated, which I just created right here. For example, settling, I would have shaker 1, UDT, process, shaker, and I would have a second shaker, shaker 2. For depositing, for example, you would have a depositor, UDT, process, depositor, and a water system, process water system. Okay, so I hope you can see the thought behind this. The idea is that these units, they can be used in different modules. You know, maybe your molding line would have different settling areas. It would have 2 depositors, for example. So by this, you're using these unit structures right here as Lego blocks, as if in a way to build. So each process module, you can build out of different units. I mean, I think that's the way I do it because I work in general with bigger projects. Of course, if your process module is just one single piece of equipment, then I would probably do the same as with the general modules. I just would make a UDT for the module instead of a UDT for a unit in the module. But again, if you think about doing bigger projects in the future, then you're probably going to have modules that consist of different equipment within one module. And then this is probably the way to go. Yeah. And I mean, one of the other reasons that I've structured it like that is because the function blocks, the reusable function blocks that we use for process, for example, in the library, are typically as well made for a unit. So for example, you will find a shaker in here, you will find a depositor. So each one of these structures would fit for a function call of a shaker, for example, or a depositor. If we now, for example, if we give an example here for the settling for the shakers. If I, for example, have 2 shaker calls in here, let's just drag them from here, shaker 1 and shaker 2 right here. Then I can do the same as before with the air supply. I can make an in-out area right here where I use the UDT process shaker. And now I'm going to add the module data to it. Let's first update these ones. DB process settling shaker 1 and shaker 2. So see, so this is the reason that I've segmented them like this. The problem is if you would have done it as a whole module, then you could have not. Then you have to put kind of the UDT of the whole module on the single shaker block, and then how to decide if you're using data for shaker 1 or for data 2. So segmentation per unit, and then each module you just fill with the correct units for that module, just like here. So it's a little bit different than with the general modules. Yeah. Okay. That's it for the global data. I mean, again, if you have any questions, write them down. I think we're going to do another 15 minutes probably on the instance data. I'll try to make it a little bit quicker because I see we're already at 1.5 hours. but now I'm going to do the final part on the instance data, and that's going to be very interesting as well, because I'm going to make some distinctions between when to use multi-instances versus when to use single instances. So, I mean, basically there is a difference between calling blocks in an FC or an FB that's only used one time in an application. Like, for example, process modules, or right here, general modules. This FC is just used one time in the application, the FC process modules as well. Sorry, there's a difference between that. And there's a difference between calling blocks in a library function, in a function that's been called or that can be called multiple times. For example, if we go to the library, for example, in the shaker, a shaker, as you've seen just before in my example, we called it 2 times already. So there's a difference which type of instance you use. And first, I will start with the blocks that are only called one time in the application, for example, FC general modules. Yeah, so what I'm going to start, I mean, this is an FC. I'm going to use exactly the same, but I'm going to create it as an FB. Because we're going to show you something with a multi-instance, and that requires an FB. So I'm going to make exactly the same function here, just FB general modules, which is a function block. All right. So this is basically the same as this. I'm just doing it as an example. And what I'm going to do now is I'll just call the first 4 modules right here with a multi-instance. And I'm going to show you how you do that. I'm going to show you what the disadvantage is of that. So right here, I'm not changing the name right now. I'm just quickly calling them to make this example. So air supply, alarm, conveyor, all defined as multi-instance. Here you can choose single instance, multi-instance, and parameter instance. Multi-instance, line control, right here, multi-instance. So 4 blocks have been called right here, and they've all been called with a multi-instance. And what multi-instance means is that the data, the instance belonging to this block, which is input, output, in, out, and static data. If we have a look quickly, it's this data right here, input, output, in, out, and static. That will be part of your instance. Temp is not part of that. This data is now part of the static area of the parent block, which is in this case the FB general modules. So that's the meaning of multi-instance, means it has been instantiated under the parent block. And now if we call this FB general modules in the OB1, right here, so I'll just delete this one and I'll call this one instead. I need to define a single instance as well. Cannot use a multi-instance here because an OB does not have a static area. So now we have, I'll put them here, we have the block call and the instance data of general modules right here. So this instance DB, if I open it, it contains these 4 multi-instances which I just created. And that's important to remember. So all 4 instances, so air supply, alarm, conveyor, line control, are under this block. Now if I make a change, if I go back here, what I want to show you now is that if you make a change, for example, in one block, air supply, for example, right here, I'll just add air supply, air fault. I'll just add some quick example. static bit here. So because I added a static, that's going to change the instance, which you can see right here. The instance is red. So you would think it only affected the air supply instance. So if you would download this, it would then reinitialize the data in that block. But if we have a look at the OB1 right now, you can see that this DB, so the parent instance DB, which has all 4 block calls, it needs to be regenerated as well. It needs to be updated. So by doing, if you would download this now, it would recompile, it would update the parent instance. And that would mean that not only the instance data of the air supply block will be reinitialized to, so the values could be back to the initial values, but as well you are going to initialize the alarm block, the conveyor block, and the line control block. So this is a little bit, this can be an issue. I mean, this is something you need to think about when you do a lot of work online, when you do a lot of edits on a running production machine, because it's kind of risky to make a change, one small change in an air supply, but as well affect the alarm block, the conveyor block, and the line control block. And as I mentioned, that you affect it because the parent instance holds all 4 instances. So if you change one of these, all of these instances will be reinitialized, the data. Now, the second way that you can do this, and I'll show you this right now, which we can do in the FC because we're going to use single instance now. So I'll delete these ones again. And this one we're going to call again in a sec. So if I now do the same under an FC, and this is the reason I'm using an FC here. If we call those same blocks and we use single instances instead, alarm, conveyor, so I all call them with a single instance. Multi-instance, by the way, is not possible here since I'm using an FC. So I'm using a single instance. So you can see I have these 4 single instances. If I now make a small change in air supply in the block interface, so static, for example, I'll put air OK. And just before I change this, I want to show you this. I'll call this FC and the OB1. So there's no instance data connected to this. So if I now change this, I get the instance data of this air supply block needs to be compiled. So you would do that by compiling the application. I'm not going to do that now, but if you compile this, then only this instance DB will be initialized. And because these ones have all been created as single instance DBs, you will not affect the instance data of these blocks. So this is what I normally do if you're calling blocks into a function that is not being used other places, just one place. I would suggest you call them with an instance DB because it is more safe when you do edits online, when you make changes during production. And the disadvantage is that you will have all these blocks here, but what I then typically do to make this neat and organized is I create a new group called instances. And you just tuck all of these instance DBs right here. And you close this and you never need to look at that anymore because they're just instance DBs. It's not something you go to very often. I mean, actually, you never actually need to go in there anymore once you call them. And once again, your application is neat and organized. So I used instances. You have more blocks, but they are nicely tucked underneath here. By using this, you don't have the risk of initializing other data when you're doing some online edits. So this was to show you the difference between when to use multi-instances or that you can use multi-instances, but that it's maybe a better idea to use single instances when you're calling blocks in an FC or an FB that's only been used one time in your application. Now it's a completely different picture when you call a block in an FB that is being used multiple places in your application, because let me just go here. Let's take for example the shaker here. So this needs to be a containerized a block of code that can be copied and pasted without any problems. And for that reason, the only right thing to do in a reusable function block is to use a multi-instance. For example, right here, if we want to add a VFD control, so it's a shaker, so it could have a frequency control for vibrating the shaker. And if I think I put it under the help function here, for example, yeah, a VFD control. So this, you cannot use a single instance here. And the reason being, if you copy this multiple times, you need to make sure that that data that belongs to the VFD control is unique for each call. And if you add a single instance right here, it will always look at the same single instance DB. So your code would just simply not work. So for multi-use function blocks, for reusable function blocks, always use multi-instances right here. So this data is now embedded here in the static area. And when you now call the shaker multiple times, which I can show you right here. We just done that. Process settling. We did 2 shaker calls in here before. So if we now call these, for example, with single instances as well. All right, and we as well create, one second, I was wrong. When we create another group instances, as I showed you, we put those underneath here. I mean, the names I have not corrected. So that's another topic. So now each one of these has their separate instance, and each instance will have a unique instance for the VFD, which we just called in here. So this code will work just fine. If we would have used a single instance right here and then called it twice, then your VFD control would have not worked. Okay, so I mean, that's basically it for the instance data. I just want to give you one final tip here, and that is that instance data should never be used outside of the block, the block you're calling it together with, because then you kind of lose modularity in your application. Instance data is just there to contain the data that you use inside that block. So I would strongly suggest you do not use tags from an instance database somewhere else in your logic. For that, for interchange of data between FBs and FCs, just use global data. Use the modular approach that I showed you with the global data, creating the modules for the general modules, the process modules, and update those modules with the data you need if there's some data missing, but then use purely global data to communicate between the different segments, the different program parts of your application. Okay, so I mean, before we're going to go to the Q&A, it's 9:45 right here in Austria, so we've done 1 hour 45 minutes. I need to wrap it up. But before we go over to the 15 minutes Q&A, I'd just like to know, what was your biggest takeaway from this session? So from the 1 hour 45 minutes going through the PLC tags, the global data, and the instance data, what was the most valuable insight that you gained? Something, you know, new and exciting that you haven't tried before, that you didn't know before, and that you're probably going to using your own applications. Just write in the text in the chat box what was really helpful for you in this session. Not much happening yet. UDTs, as Liam says, UDTs as input and output tags. Yeah, that's a good one. Yeah, that's a very useful way to structure your inputs or your outputs. Yeah. Arbab, thanks for the tips. Yeah, you're welcome. I'm happy that they were helpful for you. Yeah, when to use single and multi instances. Yeah, that's really something. I mean, I used to be all in for multi instances because it keeps your application kind of smaller. It keeps your application, you know, the less DBs, the less blocks, the more neat and streamlined. But when it comes, if you're doing a lot of commissioning like I do, and you work a lot online, I do a lot of remote work as well, where I go online with a customer through a remote connection. Then the single instances definitely have some major advantages as well. UDTs was the most important to me. Gintaras, great UDTs. Okay, maybe I should do a complete session about UDTs one day. All right, so I'm going to go into the Q&A now for 15 minutes. Yeah, so if you have any questions, and please keep it specific about the session we've had today. So if you have any questions about the things that you've seen today, maybe write question first in big letters, and then the question, so I can filter it out from the other chats. Blazer says, how do I know local and global tags? I'm not sure, Blazer, what you mean by that question. Like I told you, you can know the difference between global DBs and local DBs by right-clicking on the block. I'll show you one more time. Data. You right-click on the block, properties, and right here you see global DB under general, or it says instance DB. Hi from me with instance. Okay, instance tags. Yeah, thank you, Lou. Instance DB static error by default. Yeah, good question, Lou. Let's take, for example, yes, you're right. Normally, the instance DB area is accessible from HMI. Yep, I always unclick those things. I always untick these boxes because that's actually something that I was going to tell later, but I can just tell it right now. That's one last thing that I wanted to say is that I think you should only use global data in your HMI application. So you should never have instance data coming as far as your HMI application. That's like I think that's a cocktail for disaster, or how you say. You should just have global data connecting to your HMI, tagging up to your HMI. Instance data should purely be in your PLC application and only with your block call. So yes, I do untick those boxes. Same with local tags, Blazo. I mean, I would only in global DBs. I'll show for other people who maybe not. I'll just open one of these previous one. You have these tick boxes here. Accessible OPC. It's probably OPC, HMI, writable, readable. So these boxes right here. It says if these tags are visible in an HMI, are they visible in an OPC UA environment? So for global tags, yes, I leave them there. For instance tags, I untick these. Sheriff says how to create UDT. I just showed you that, Sheriff. So if you go back afterwards to the recording, you can check it out again. Andre has a question. Does using global data only, no marker memory, shorten the cycle time, or does it take more memory area only? I mean, personally, I don't even care that much about the cycle time. I mean, I never really had problems. I think TIA controllers are so powerful. I never really had problems with cycle times. I'm typically somewhere between 1 and 5-6 milliseconds in my applications, which is more than fast enough. I think for me the main reason never to use markers is you can build structures. I would never use single tags in my applications. They're always part of some structure. The only single tags I would have is for commissioning maybe, but I would even put those in a commissioning DB. Alexander says, how to solve the cross-reference problem with the in-outs? Well, you can solve it by, like I said, like instead of using them as an in-out, just defining them as inputs and outputs. So all the necessary tags from that structure that you need in that block, just add them as inputs and outputs, because then you can find them in your cross-reference. Let me check that I don't. Rick says, question, how do you use these structures if you have to use SCADA application, physical? Sorry, Rick, no experience with SCADA here. Physical address instead of... No, okay, you're talking about physical... Yeah, okay, but that's something else, Rick. So you're talking about the physical addresses right here. These are the physical addresses, for example, offset 0, 2, 4, 6, 8. This would be what you would use in SCADA, or what you would use to sometimes upstream communication, downstream communication. You as well need a physical address, which you have here. And the difference is that this block is non-optimized. So if you look right here under attributes, I just went into the properties, the attributes, the optimized block access. If you enable that, then you will lose the hardware addresses. I mean, they will still be internally running in TIA portal, but you cannot see them. Or it then you allow them to optimize the block access, so it will internally reorganize the blocks for the least amount of space. So you can still do that with SCADA. You just need to put it, just untick the optimized block access right here. Let's see, let's take a couple more here. I've maybe 10 more minutes. Alexander, does TIA portal support OOP? Just, sorry, maybe someone else in the group can answer that. I'm not familiar with CodeSys. I mean, it looks very interesting, and I know a lot of people are raving about it, but I'm not a Beckhoff guy, which is one of the main vendors that use CodeSys. So yeah, can't answer you there. As you said, in-out variables have a difficulty in troubleshooting. I use them a lot. Can elaborate more? Yeah, as I said, Chris, put them as separate inputs and separate outputs. It doesn't make a difference to the structure. So the modular structure you would build anyway. And then you would add them as separate inputs and outputs instead of in-out. You lose a little bit of performance, but if it's going to be noticeable, I never did the tests putting everything as in-outs, inputs and outputs compared to everything as in-outs. It's what Siemens dictates. Yeah, I think if you do have a lot of communication with structures, then it's probably the easiest to make in-outs, not to end up with a huge function block, because that's not so nice either. Rick has a question. Please revisit the question of Chris. Do you use the PLC tags directly, or do you create another DB to map the tags and then use the DB tags for the... Yeah. So, for example, when it comes to these, for example, these system and clock memory, let me just show you right here. PLC tags. It's getting a bit late. I can see I'm getting a bit confused. So these system flags, no, I would not use them. For example, these, I mean, that's the only marker bits I have left because they're automatically generated. I would make a small function that copies them over to a DB. So I would, under DB, have, for example, general, a function that's called general system flags or general system functions, something to do with the system or with the PLC or PLC status, PLC flags, and then under there I would map them to a DB, and then only use those DB values. So map them to again, make a structure, for example, a system flags data structure, and then map them under there. Alexander, are you going to do a session on what are the overall considerations before starting a PLC program for an industrial machine? It's a good question. Yeah, I might do one about that. I think I might make some kind of, send some email out where I'm asking people what they would think would be interesting for another live session. Sheriff QA, can we create timer tag in UDT? You can create a time, but a timer itself, good question. I mean, there's a lot of things you can and you can't. Let's have a look. I don't think so, but I would have to. I mean, I typically don't use it. I mean, I don't even know if I'm just thinking if it would be a good idea to do that. I'll just try and add it here. I don't think so. Nope. Timer. Let's try TON, IEC. Okay, apparently you can. You can. There you go. I mean, I haven't used it yet, but you can if you want, Sheriff. Eric, I used to map input outputs and FC to UDT hardware and then use FB control, that instruction, other in-out for you dealing with the config. Inputs and outputs in FC. Yeah, that's maybe a different way of doing it, Eric. I mean, I would normally not map inputs and outputs. I mean, if you would do mapping of inputs and outputs, that's good if you want to manipulate them. For example, if you want to be able to force inputs or force output states, which can be a good thing during testing of the line before commissioning, testing at the machine builder. Then I know some customers of mine have done that before, where you kind of have an interface between the input and the actual inputs that you use in the software. That would be through some kind of manipulation, through a forcing or something. Liam has a question, why do you use non-optimized DBs? No, Liam, just to make it clear, I don't use non-optimized DBs. The reason they're in here is because I started from a messy application. So I I kind of created a messy application based on some of my own applications. So that's why these DBs are non-optimized. I would optimize them. I always use optimized unless, like one of the other questions was, unless there's some kind of communication to SCADA that requires that you have a hardware address. Mopi says, is it recommended to use master UDTs to include other UDTs when we need to interface lots of input outputs? Yeah, I'm not really sure about the question, Mo, but yeah, sometimes I would use UDTs within UDTs, but most of the time I would just use a struct, and then I would use that whole UDT as a module. But in some cases, it maybe makes sense, to use UDTs within UDTs. Can you show us how to create codes for status commands and others? Yeah, Chef, that's going to be in another live stream, another YouTube video, maybe part of another course. How can we transfer data from other? Saber, pointing addresses is again pointers, the old-fashioned pointers in some Semantic Manager. You don't use those in TI anymore. Anyway, I got rid of those. You have indirect addressing by using an index tag, same as maybe people who are familiar with Rockwell. They were doing that long time before, but so that's more if you do indirect addressing in arrays, for example. other than that, if you make structures like this, there's no real, unless you use arrays, like I said, with indirect addressing. But if you use structures like this, I have not had the need to use pointers anymore. I mean, if you want to give a specific example or any of the other questions maybe that weren't answered, you can write them to Hans at plcskilltree.com. Okay, I'm going to do 2 more questions and then I need to. Final question, if you add a new tag and a UDT, isn't the whole process DB going to initialize and lose the data from the other modules inside the DB? That's a good question, Chris. I mean, I don't think so. I can't say 100% without trying it, and we're kind of out of time here. I would have to try it, Chris, and we'll get back to you. Can you put that on an email to me as well? Because that's a very interesting thing to test. And finally, hours. What are you drinking? I was drinking a berry juice with carbohydrated water. Thanks for asking, but it's finished now. My throat is getting a bit rusty. So I think we're gonna end it here. Sorry, Eric. It's 10 o'clock in Austria, and that's bedtime. So yeah, thank you for joining. And again, like I said in my last session, if you like this session, then you're really going to love my free guide. So if you haven't tried my free guide on structuring PLC applications in TIA Portal, then go and check out the description below this video. There's 5 easy steps to drastically change your PLC application. There will be follow-up emails with more value. There will be more videos. So once you subscribe to my newsletter through the download of the free guide, you will get more emails. You'll be part of an email sequence with lots of value. So don't miss out on that one if you haven't got the free guide yet. Last point, if you haven't watched the previous session, if it's all a blur what we've seen here and you're not sure what I mean with the molding line and everything, then go and watch the previous session again, or watch it if you haven't watched it before, watch it for the first time. So yeah, I hope you have an amazing start of the week, and I'll talk to you next time. Bye.